Hello everyone, welcome back to my another tutorial. Last time I showed you how easily we can crack simple captchas, how we can solve them with Python. So right now I decided to move on to harder tasks because it's pretty hard to find a captchas dataset that I might use. I decided that why not making handwritten words recognition? They're very similar to captchas, they might be hard, they have different length in text, so I decided to move on with this. So I decided to use IAM Dataset. That's kind of open source dataset that has a lot of words, sentences, pages with handwritten text. And this is open sourced and released pretty 20 years ago, but who cares if I want to learn to recognize handwritten text? As well, you can change this handwritten text to captchas, and here we go, you have a solver for your captchas. Later I'll move on to a harder task, is handwritten sentences recognition, and this is the part of OCR system that's where is the great point to start beginning your own OCR implementation. But talking about this handwritten text, nowadays it's still very popular because usually we need to, for example, read a whole handwritten text document. The easiest way is to scan the document and give it to the algorithm to recognize each word or each sentence, transcribe it into readable text and move on. So also you can use it for your students' exams grading or essay reading, or I don't know, old papers to digitization from handwritten to digital text, and etc. There is a lot of opportunities where you could use this kind of handwritten recognition. And one very great point that this kind of data set is used for benchmarking your OCR with handwritten. You can find online a lot of OCRs where they tell us the benchmark with the test data set or etc. how well they were able to solve this kind of handwritten texts. So I decided, okay, let's move on with this kind of implementation. First thing, I think that we need to install the requirements. I will use Python 3, I'll use TensorFlow 2.10. It's necessary to know, don't go to 2.11 if you are on Windows. So because they changed a lot of stuff there. And next I use my ML2 package 0.1.5 for this tutorial, so I recommend to install this kind of version. In the future it might change because, well, I will be working on this repository, improving it, adding a lot of stuff, changing books, fixing everything, documenting. I'll try to improve this kind of library for all of us to use it massively. Okay, so let's move on with this kind of task, and I'll first want to show you how the dataset looks like. As you can see, there's a lot of words. It's pretty hard to read for us. Of course, there's a lot of easily readable text, but I don't like the dots here. They are misunderstanding in this dataset, but okay, never mind right now. Right now, for example, I have this kind of data set, I have all these words and etc. And I downloaded this from a specific link, and the link you can find in my text version tutorial. I'll add the link below this video. So if I go to here, there is a words annotation file where it gives us the paths all to these words and etc. Gives us all the documentation. So this is the ID of the folder, then the folder, another folder ID, and there is a full name of my target image. And this tells that, for example, it's everything okay with this, it's annotated correctly. And for example, if we go down, there is an error, as you can see. So we will skip these kind of errors. And there's at the end, there is the grammatical tag, there is the actual value for our text. I mean, I think that's the last sign, this one, yeah. So we'll need to create this dataset. So right, let's move to the code, I believe. That's the most interesting part, how I implemented everything in code. I have here a handwritten recognition tutorial. It's a train model, inference model, and configurations. I'll move on to all of these with a little amount of time for you, just step by step. So here is all my MLTU training stuff, the losses, callbacks, metrics, augmenters, transformers, preprocessors, and etc. and data provider. But first thing, we need to download this kind of words dataset. It's pretty huge dataset. I don't know. I believe it's 4 gigabytes. How much it takes? Oh, it's not too large. It's 800 megabytes, but still it takes some time to download. To download this dataset, I wrote a short script that uses a requests library to do so. So simply you need to give a link to this zip file where it lays down on the internet, and my code will handle it for you. And you'll see that TQDM bar going from left to the right while it's downloading. So wait for it to finish, and then you won't see, but it also takes a lot of time to extract these images because there's a lot of files in this RAW. So yeah, it takes a lot of time. So don't hesitate to wait. So I believe it's way easier to run this script than downloading it manually and placing it into datasets, etc. This file will prepare everything for you. So next, we need to work with this annotation file that I already show you. And the idea here that we are skipping this kind of sign if it's is at the beginning. You can see then we skip the word if it's an errored word, and then we split the IDs of the folder. We collect full path to our file name, and last thing, we take the last element from our list. That's the actual label, so that's the last word. So Mr. Gatescale and etc. And that's it. We collect this data set and it will be appended to this file, and this will be list of list where the first element will be full path. No, it will be relative path to my dataset, and the second will be the actual label. Then I collect the vocabulary, that is kind of all the different characters that are in my labels, and then I collect the maximum length of single word. So this is also going to be used. And then I make a configurations, and if I go to my configurations, you can see that here I have my model path where I'll say my trainable model. I have vocabulary that I'll update with when I iterate through dataset. I have different width, height, maximum length that I'll update, batch size, learning rate, training epochs, training workers, and etc. That's kind of basic stuff. We go to the train, and here I update my configs as I mentioned. And then I use my data provider for this kind of data set. That's my custom script made for TensorFlow models. It's pretty useful, very useful, and it's inherits from sequence, but it has a lot of features that, for example, you can feed any data and preprocess is used any way you want. So for example, right now I have images, so I give it an image reader and it will read all the images from here. I could give a resizer here to data preprocessors, but I'm giving it to image to the transformers, because actually we are transforming image size. Then we could use keep aspect ratio as true. It will, when we are resizing our images, then for example the left and right sides are padded if that's an A, but for now I decided to train it like that. And if you're interested to test how it works with padding and without padding, it's up to you, but you'll need to change the inference model code especially for that. So then we use a label indexer. We need to transform our string into a numerical type. So I need to transform all my labels according the vocabulary to the index. Then later, after the model is trained, it will be really easy to me to transform it from integers back to string words. And then I need to use a label padding so because our models are accept only the same size input, all the labels should be the same size. So this means if we, for example, have A and another word is home, we need to add additional 3 padding symbols. And well, the padding value will be the additional value from vocabulary rank, and yeah, that's it. And other thing our code will handle for us. We don't need to worry. And so next, I'm splitting the dataset into 90% and 10% for validation, and that's it. And of course, I'm using the augmenters, and I'll only apply these augmenters to the training dataset because, well, we want to achieve better results, and there's no better results than applying, for example, augmenters. So this means that that's a similar way to getting a larger dataset. Okay, and then I'm defining my trainable model, and it's very similar to the previous tutorial where I showed how to train a Captcha, but right now I believe I have different tries here because my words are longer, so I need more details here. So that's it about that. And then I simply compile my model with IAM Optimizer. I use CTC loss, of course. It's one of the easiest way to recognize words, sentences, sound from, and etc. And of course, I using character word error rate metric. In the next tutorial, I'll use another metric. I'll separate character and word error rate because, well, it's not a good practice, but for now it's totally fine. And then I use it to print the summary. And then I'm using 6 different callbacks, and yeah, it's early stopping, not to train forever our model. Checkpoint only to save the best model or according to the validation character error rate. And this is kind of rate that shows us how many mistakes our predicted word did according to the true label. And of course, we want as less mistakes as possible, so we track this character error rate. Of course, we could track the word error rate, then it means how many correct words we were able to predict, but right now I'll focus only on character error rate. Some kind of logs, training logs, that's for debugging, etc. TensorBoard, I'll show you some graphs of the TensorBoard, not to wait me to train the model while I'm recording. It might take a lot of time. And of course, decrease the learning rate while it's not improving after 10 epochs. Well, it could be better, but that's totally fine for now. And of course, I'm converting my model to ONINX format after it finishes training. And yeah, I believe that's it. And then I call fit, and then I save my training and validation data set together along the model in case I would be interested to change in architecture of the model, in case I would focus on increasing the character error rate or accuracy or etc. Well, or I add additional augmentations. That's a good way how we can validate our models. And yeah, if you're interested, I can run the training, of course, and we'll see the model summary and see that this code works just fine. And it will start training, but idea is not about that. So, okay, yeah, let's wait it to finish loading the data. Okay, as you can see, we had a huge data set that's 150,000 of different handwritten words images. That's a lot compared, and you might see that this is the architecture of my model. I grabbed some ideas from the ResNet implementation to implement this kind of residual blocks or convolutional blocks, I don't know how you call it. And these have a skip connections to better work with these kind of convolution networks, not to overfit the model and etc. And if I go back, Here you can see the input is 32 by 128 to resize the image. And then at the end, I have some kind of reshape where I multiply this 4 by 16 and I reshape to 64 by 64, and then I feed this information to my LSTM network, and after LSTM network I simply receive these kind of values, and this information goes straight to the CTC net loss, and it goes back, and then, well, it's 75 time steps and 64 length of the whole string that will be decoded with CTC. That's if you're interested in what is CTC and haven't watched my previous tutorials, I recommend to checking them. And in my first tutorial I explained how the CTC works more in detail, and you might get familiar with that because, well, I don't want to explain it again. And that's it. As you can see, it keeps training, and yeah, who cares about how it finished? And I would like, but not to wait to finish. I already trained the model before, and let's go to TensorBoard. I'll show you the results. I need to cancel this. I don't want to use my GPU. Okay, I go back. And here I have my TensorBoard, and as you can see, I trained it a few days ago. Actually yesterday, and yeah, it goes down like that. And here you can see that orange is training and blue is validation, and we definitely can see that the child rate was decreasing and model was improving, etc. But, well, what's worrying is these kind of spikes on the validation data, and it's really hard to explain why they're here. But it might be that my training validation data is not perfect because of these commas, dots, and other signs that are simply without a word. This is a habit for our model to learn what they actually are. So I believe that's the reason. If I would be removing them, we could get a better results, but that's not the point of this tutorial right now. I want to show you the way how easy it actually is to train it. And here also is the word error rate that gives us how many correctly words were predicted with our model. As you can see, 20%, well, actually 80% of words were bad, and mostly that's possible with this with signs, dots, and etc. So yeah, we'll need to work a little more with this data set, with pre-processing, etc., if you want to get good results. But right now that's not the point of this tutorial. So let's move on, and I believe you want to see how actually it works. And if I go to my model, I have here an inference model script that I already prepared for you, and here is my trained model that you can download from the link in my text tutorial. I added the link where you can download the model if you don't want to train, and of course the validation CSV files and etc. And here I simply reading the image and using the model to predict, and the model is here image to word. That's an ONNX format model loaded. And why I use ONNX? Because, for example, if I would be interested to port this somewhere else to different device, I don't need to install TensorFlow or etc. Huge libraries. I simply need to install ONNX runtime and I'm good to go. And yeah, I'm good to go actually. And of course, I will resize the image for you and I'll show you actual predictions. And yeah, let's run this script and we'll see how this actually predicts our image, what results we get. So let it load. What the hell is that? Okay, sorry, this should be image show. Yeah, that's correct. Let's reload this. I wrote this by mistake. That's my mistake. Sorry for that. And let's look at it, how it looks like. It's loading. Oh no, it's here. So This is my first image, and you can see that the prediction was upon and label was upon. That's correct. It's even hard to say what it's written here, but not. That's right. This appears. Well, it's not that easy for me to tell what's actually is there, and you can see that my model, it predicts the actually correctly. That's the comma. Who the hell knows that that's the comma? That's kind of shit. Because label, because, and prediction, because. That's fine. And Premiere, well, there's a lot of label. Oh, here we have an error, August A. It predicted R here. So that's cool. And you can see that that works pretty amazing. And that's the easiest way to train any word detector you want by using my code. Of course, you can find it on GitHub. The link is below this video. You can find all the video details, how you can train it within the code, etc. in my text version tutorial. And of course, don't hesitate to like, share this video, and leave the comment if you have any questions or suggestions what I should do next. And I really hope that this video will be useful for you if you are learning Python, you're developing your projects, or even if you're working or doing something for your, for example, task, job, or etc. It's up to you where you're gonna use. I really hope you're gonna like it, because, well, I appreciate when that's helpful, because I spent some time doing this, writing, documenting, making it clear, understandable, and open source. Of course, nothing pays me for that. And I really hope that we'll see you in our next tutorial, because that's the end of this one. And in the next part, I'll try to recognize full sentences instead of words, and I'll make another tutorial. And then we'll go to the harder stuff with sound recognition. We'll see what we can do with that. So thank you all for watching, and see you next time. Goodbye.